Hello and hi everyone. Alright, today I will do the assignment or task was given by my lecturer under the course of SSCM 1523, which is the name is Linear Algebra. I'm from section 3 and I taking this course to session 2021. And this course under the Faculty of Science and my lecturer is Dr. Ahmad Fadilah bin Abong. Alright, before I start my presentation, I will introduce myself first. My name is Muhammad Azman bin Cik Hamid. My matric number is A20SC0137. And I'm first year student from Faculty of Science and I'm taking the course of SSCFH, which is Bachelor Degree of Science in Industrial Physics with Honors. Right. Actually, the task was given by my lecturer is I need to teach, explain and give simple briefings about the topic I choose. Alright, I choose a chapter 1 which is matrices as my topic that I want to discuss today. In this topic, have 8 subtopics which is start with the matrix notation and terminology, type of matrices, matrix operation, place of matrix, elementary row operations, rank of matrix, determinant of matrix and inverse of a matrix. Alright, but I will discuss only the subtopic 5 which is elementary row operation, ERO. Right, like the name, elementary row operation, in this topic have 3 operations that we need to know. The first one is interchange of row. The second one is multiplying a row. And the last one is adding a multiple row to another row. Okay, I will explain one by one of these operations to you guys to make you guys understand. Alright, let's go for the first one, which is interchange of row. Alright, like the name, the interchange of row, and this under the topic of matrices. So we need the first one we need is matrices. This this what you call it, 2 by 3 matrices. Alright, you can you guys can see that the entries I choose is 1, 2, 3, 4, 5, 6, the simple one. And before start the interchange of row, we need to know the row. Alright, the green one is row 1, the blue one is row 2. That's a simple. Alright, and then we do the arrow and use this symbol. Use this, which is row 1, this arrow, and row 2. What the meaning of the arrow? This arrow means the interchange. So what we need to do is we need to change between row 1 and row 2. So the result is become like this, which is row 1 become row 2, row 2 become row 1. Right, that's simple for interchange of row. Let's move on to the second operation, which is multiplying a row. Alright, so I continue with the entries 4, 5, 6, 1, 2, 3. Right, multiplying a row. First one, we need to choose a row that we want to multiply, which is I choose row 1, the entries 1, 2, 3. So I will multiply row 2 with negative 2. So and the name so this one negative 2 we call as k, and then when I multiply, you got like this. So negative 2 multiply row 2, you will get negative 2, multiply 1 you get negative 2, negative 2 you multiply with 2 you get negative 4, and negative 2 you multiply with 3 you will get negative 6. But need to remember that this k not cannot be non-zero. This k must include must multiply by non-zero, and that's mean k cannot be zero. Right. So the last one is adding a multiple row to another row. Like you guys can see that I choose the entries 4, 5, 6, negative 2, negative 4, and negative 6. Alright. For this operation, it's simple complicated. It's a simple complicated, but you guys can you guys can understand this topic if you guys listen and carefully to what I want to explain. Right. First one, we need to do the arrow, of course, and then we need to choose one row that we want to change the entries. So I choose row 1 that I want to change the entries. So what I need to do is I will write R row 1 on the back, and then I will add the symbol of plus or addition. Remember, always put addition or positive after the before the row that we want to change the entries. This what you call it, the condition that you need to follow. Alright. So I will choose another row, which is we already choose row 1 that we want to change the entries. So I choose another row, which is row 2, to multiply with an integer. Alright, let's say that I want to multiply this row 2 with number 2. So you will get like this. So the operation on this is negative 2 times by R2 plus R1. So you guys can see that the operation are like this. So you take the 2 over here, and row 2 you looking on the row 2 -2, so plus by r1 row 1, which is 4, so you will get 0. So continue by the operation, you will get this answer 0, -3 and -6. So the answer for operation of adding a multiply row to another row, you will get like this. You guys can see that the row 1 that I want to change is already changed. You can see already changed, and the row on the front that remain constant. You guys can see like that. Alright, so let's move on to another example. Alright, this I will show you guys a simple example that I made, that I add, including the tree of operation, which is the addition, this operation, which is interchange, multiply, and addition of multiply row to another row. Right, so I choose matrices 3 by 3. So you guys can see that I use entry 1 2 3 4 5 6 7 8 9. Alright, to make you guys understand deeply about what I want to explain, I already label the row, which is label the blue one for row 1, green one for the row 2, and the red one for the row 3. So this will make you guys understand deeply about what I want to explain. Right, first one, I choose the operation interchange of row. So you guys can see that I want to change between row 1 and R2. So the result you guys can get is like this. You guys can see that row 3 is remain constant because I don't want to touch the row 3. I just want to touch row 1 and row 2. So you guys can see that the row is exchange, right? The row is exchange, or we call it interchange. So I will move to further operation, which is I will multiply a row with an integer. Remember, the k must be not 0. You can multiply with another integer, but not 0. Alright, so this the operation called as multiplying a row. So you can see that I want to choose row 2. I want to multiply row 2 by 2. So you guys can see that row 2, the first one is 1, you get 2, and 2 times by row 2, you get 4, and 2 times by 3, you get 6. Okay, that's the operation. So what the result of this operation? You can see that for the row 1 and row 3 is remain constant because I do not touch the row 1 and row 2 of the matrices before that. So the only change is row 2, which is 2, 4, and 6. Alright. Now I will do the operation of multiplying a row by another row. So you guys can see that I choose the operation. So remember, this operation give a meaning, which is when I put R3 on the back, I want to change row 3. So when I put R2 on the front, that means I want to use row 1 to change the row 3, like that. Okay, so I put a -2 on the, so I will I will use a simple multiplying a row over there, which is -2 times R1 time by R1. So this called as adding a multiple row to another row. So the operation you guys can see like that, -2. So start with -2. Okay, R1. I take R1 4 and then the operation plus R3. So I take the R3. So you guys can see that the result is -1. So, sorry. So you guys can continue the operation and you guys can see the result is like this. So like I said that I just want to change the row 3. So the row 1 and row 2 not change. It's remain constant before like the matrix like the matrix on the back. You guys can see that 456 456 246 246 is not changed because I just want to change the row 3. So you guys can see that the row 3 from 7 8 9 changed to -2 -1 -2 and -3 because the operation that I use over here, sorry. So I will adding a more I will add another operation which is multiplying a row. So it's simple like it's same like this. So you guys can see the operation 4 is constant. So from the R3 I choose the R3 which is 4 times -1, 4 times -2, 4 times -3. So this operation, so you guys can get so you guys will get the result. You guys can see that R1 and R2 not changed because I just want to touch the R3. So you guys can see that the result of entry for row 3 is changed, which is from -1, -2, -3 become -4, -8 and -20. Sorry, -20. Sorry for -12, right? So that's a simple example that I combine all the three operation. So you guys may know it is only elementary operation simple like that. Actually not. It have two type of elementary row operation, which is the first one is row echelon matrices, we call it REM, and the second one is row reduced echelon matrices RREM. What difference between these? Alright, I will explain simple briefing. I will give a simple briefing what the difference between this type of elementary row operation. Alright, before that we need to know that the properties that must have to become REM or RREM. Alright, first one, you need to consist at least non-zero row, not a zero matrix. Remember that. The second one is the leftmost non-zero entries in every row is one, and we call it as a leading one. And then the third properties is the leading one in the lower row occur further to the right than the leading one in upper row. Okay. For the last properties, for the REM, which is row echelon matrices, we need to if has any row consistencies with all zero, they will group together at the bottom. So what the meaning of this? Okay, you guys can see that this is a simple example of REM, which is for the first properties consists at least non-zero row. Okay, consists at least non-zero row. You guys can see that have over there, and then the leftmost non-zero entries everywhere is one. We call as leading one. So you guys can see this we call as leading one. To the leftmost we call this leading one, and for the third properties the leading one lower row in the lower row occur further. So you guys can see that for the second row, the leading one to the right. So it's further to the right than the leading one and the upper row. So it's already consists the three properties. Alright. For the four properties, if has any row consists entry with all zero, they will group together. So you guys can see that the all entries with all zero group together at the bottom. So this example already including four properties. So we call it as row echelon matrices. Right. And the last one, actually for the row reduced echelon matrices, RREM, the properties same like row echelon matrices, REM, but we include the another properties which each column that contain leading one as zero everywhere else. So you guys can see that the properties already include of the example, but you guys can see that for the leading one below it 0 0. So for the leading one, for the right one, you guys can see the upper and the below of the leading one is 0. So you guys can see that if row echelon matrices, every if we have leading one, under it must have none 0, which is the entries must be, sorry, for my mistake, uh, for leading one, under the leading one must become 0. But for the for the row reduced echelon matrices, or REM, under and upper of leading one must become 0. You guys can see like that. That's a simple difference between REM and RREM. Alright, actually, for the row operation, elementary row operation, it's, the sorry, the relationship between elementary row operation between REM and RREM, actually, the question may ask you guys to, for example, if give us matrices and you guys to make become row echelon matrices. So you guys do the operation, which is the adding, the interchange of row, and the multiplying a row with another row. So you guys use the three operation to get this answer to consist of all the properties. That the use of elementary row operation. Alright. I hope you guys can understand deeply about what I want to explain about elementary row operation. Guys, that's all from me. Thank you. See you guys and another topic. If I have yeah, if I get the task again. So yeah, see you guys. Thank you for listening and watching my video.